based on your uploaded draft. What would happen if you fell into Jupiter? The answer is not just terrifying, it is almost impossible to imagine. You would not land on solid ground. You would not see mountains, oceans, rocks, or soil. You would not step onto a surface and look around. Because Jupiter has no real surface at all, it is not a rocky planet like Earth. It is a gas giant, an enormous world made mostly of hydrogen and helium, wrapped in thousands of kilometers of violent atmosphere. From far away, Jupiter looks beautiful. It looks calm. Its colorful bands make it look almost like a painting floating in space. But if you got close to it, you would realize something very quickly. Jupiter is not a peaceful planet. It is a monster. It is the largest planet in the solar system. It is so massive that all the other planets combined still cannot match it. Mercury, Venus, Earth, Mars, Saturn, Uranus, and Neptune could all be added together, and Jupiter would still be more than twice as massive as all of them combined. Its diameter is about 11 times larger than Earth's. If Jupiter were hollow, more than 1,300 Earths could fit inside it. 1,300 Earths. Every ocean, every mountain, every city, every forest, every human being who has ever lived, all of it could fit inside Jupiter many times over. And yet Jupiter is not a star. It is close to being something even stranger, a failed star. Not because it actually failed at anything, but because it is made of the same basic ingredients as the Sun, mostly hydrogen and helium. If Jupiter had been much more massive, its core might have become hot and dense enough to ignite nuclear fusion. It might have become a small star, and our solar system could have had two suns, but Jupiter never crossed that line. It remained a planet, a gigantic storm-covered gravity-dominated world that is almost a solar system of its own. Jupiter is so far away from Earth that the distance between us is hard to understand. Because both Earth and Jupiter orbit the Sun, their distance is constantly changing. Sometimes Earth and Jupiter are on the same side of the Sun, and Jupiter is relatively close. Sometimes the Sun sits between Earth and Jupiter, and the distance becomes much greater. At its closest, Jupiter is roughly 600 million kilometers away from Earth. At its farthest, it can be more than 900 million kilometers away. Even light, the fastest thing in the universe, takes more than half an hour to travel from Jupiter to Earth when the two planets are near their closest positions. Think about that. Light can circle Earth more than 7 times in 1 second, but even light needs over 30 minutes to cross the distance between Earth and Jupiter. If you tried to travel there on one of the fastest trains on Earth, moving day and night without stopping, without slowing down, without ever taking a break, the journey would take far longer than a human lifetime. You could board that train as a newborn baby, grow old, live your entire life and still never arrive. That is how far away Jupiter is. And yet from Earth we can still see it shining in the night sky. It is often one of the brightest objects above us, outshone only by the Sun, the Moon, and Venus. For thousands of years humans looked up at Jupiter without knowing what it truly was. Ancient people saw it as a wandering star, a bright point of light that moved differently from the fixed stars. But through telescopes, spacecraft, and modern science, we now know the truth. That bright point is a gigantic world, a world bigger than anything else orbiting the Sun, a world with storms larger than Earth, a world with hidden rings, a world with auroras more powerful than ours, a world surrounded by dozens of moons, some of which may be among the most promising places to search for life beyond Earth. But before we talk about those moons, we have to understand Jupiter itself. Because Jupiter is not just big, it is extreme in almost every way. First, its rotation is unbelievably fast. Earth takes about 24 hours to spin once. Jupiter takes less than 10 hours. That means Jupiter has the shortest day of all the planets in the solar system. A planet 11 times wider than Earth spins so quickly that one day on Jupiter lasts only about 9 hours and 50 minutes. By the time you wake up, eat breakfast, go to work, and come home, Jupiter may have already spun around more than once. This fast rotation has a huge effect on Jupiter's shape and atmosphere. Jupiter is not a perfect sphere because it spins so quickly. Its equator bulges outward. The planet is slightly flattened at the poles and wider around the middle, and this rapid spinning helps create the striped appearance that makes Jupiter so recognizable. When you look at Jupiter through a telescope, you do not see a calm, smooth ball. You see bands, white bands, orange bands, brown bands, cream-colored bands. These stripes stretch all the way around the planet, like giant belts wrapped around a spinning world. But these are not solid markings on a surface. They are cloud bands. They are layers of atmosphere, moving at different speeds and in different directions. The lighter bands are called zones. They are regions where warmer gas rises from deeper inside the atmosphere. The darker bands are called belts. They are regions where cooler gas sinks downward. These bands are separated by powerful jet streams, and some of them move in opposite directions at hundreds of kilometers per hour. At their boundaries, the atmosphere becomes chaotic. Clouds twist, winds shear, storms form, vortices appear and disappear. Jupiter's atmosphere is not just weather. It is weather taken to a scale that Earth cannot compete with. On Earth, a hurricane can be devastating. A typhoon can destroy cities, flood coastlines, and tear apart buildings, but on Jupiter, storms can be larger than entire planets. And some storms do not last for days or weeks. They last for centuries. The most famous of them all is the Great Red Spot. If you have ever seen a picture of Jupiter, you have probably noticed it. A huge reddish oval sitting in the planet's southern hemisphere, like a giant eye staring into space. That is not a surface feature. That is a storm, a colossal anticyclonic storm that has been raging for at least hundreds of years. When astronomers first observed it centuries ago, the Great Red Spot was already there. During the age of sailing ships, it was already spinning. During the Industrial Revolution, it was still spinning. During the first moon landing, it was still spinning. And today it is still there, a storm that has outlived generations of human beings. At its largest, the Great Red Spot was wide enough to fit multiple Earths inside it. Even now, after shrinking over time, it is still larger than Earth. Imagine a storm so large that our entire planet could disappear inside it. Every continent, every ocean, every city, every person, all swallowed by one storm. That is the scale of the Great Red Spot. The winds around it can reach hundreds of kilometers per hour. The storm rises above the surrounding cloud layers like a gigantic mountain of atmosphere. And the strangest part is that we still do not fully understand it. Why has it lasted so long? Why is it red? What keeps feeding its energy? Scientists have ideas. They believe Jupiter's fast rotation, deep atmosphere, and powerful jet streams all help maintain the storm. The Great Red Spot sits between bands of atmosphere moving in opposite directions, almost like a spinning top being pushed from both sides. But even with spacecraft observations, the Great Red Spot remains one of the great mysteries of the solar system. And it is changing. Over the last century, the storm has been shrinking. Its shape has become more rounded. Its color changes over time. Sometimes it appears deep red, sometimes pale orange, sometimes almost pink. No one knows exactly how long it will survive. It may last for hundreds more years, or it may slowly fade away. But for now, Jupiter still carries this enormous red eye on its face, watching silently from the outer solar system. Now imagine falling toward that world. At first, from space, Jupiter would look magnificent, a giant sphere of swirling clouds, white, orange, brown, gold, the Great Red Spot rotating slowly in the distance, faint rings circling the planet like a ghostly halo, moons moving around it like tiny worlds in orbit. But as you got closer, beauty would turn into danger. The first thing you would notice is the gravity. Jupiter's surface gravity, measured at the cloud tops, is about 2.5 times Earth's gravity. If you weighed 100 pounds on Earth, you would feel like you weighed 250 pounds near Jupiter's cloud tops. Every movement would become exhausting. Your body would feel crushed under its own weight. Your heart would struggle. Your bones and muscles would feel an unbearable heaviness. But you would not be standing. You would be falling down into the clouds. There would be no solid ground to stop you. You would enter the upper atmosphere, where temperatures are extremely cold, around minus 150 degrees Celsius. The clouds around you would be made of chemicals very different from the clouds on Earth. On Earth, clouds are mostly water droplets or ice crystals. On Jupiter, the upper clouds contain ammonia ice. Below them may be clouds made of ammonium hydrosulfide. Deeper still, water clouds may exist under enormous pressure. Layer by layer, you would fall through an atmosphere that becomes darker, hotter, and more pressurized the deeper you go. The winds would tear around you at incredible speeds. On Earth, winds above 200 kilometers per hour are catastrophic. On Jupiter, winds can easily reach several hundred kilometers per hour, and near powerful storms, they can become even faster. You would be thrown, spun, and battered by endless turbulence. There would be no horizon, no ground, no sky in the normal sense, only clouds above, clouds below, clouds in every direction, and as you fell deeper, the sunlight would begin to fade. The upper clouds would block more and more light, the atmosphere would grow darker, the pressure would rise. On Earth, if you dive into the ocean, every 10 meters adds about 1 atmosphere of pressure. Go deep enough and the pressure can crush submarines. But Jupiter's atmosphere goes far beyond anything found in Earth's oceans. As you descend, the weight of the gas above you becomes enormous. Hydrogen and helium, which seem light and harmless on Earth, become compressed into dense fluids. The boundary between gas and liquid becomes unclear. There is no ocean surface you would splash into. Instead, the gas would gradually become thicker and thicker until it behaved more like a liquid. Keep falling, and hydrogen itself begins to change. Under extreme pressure, hydrogen molecules are crushed so tightly that they enter a strange state called metallic hydrogen. Metallic hydrogen is not metal in the ordinary sense. It is hydrogen forced into a state where it can conduct electricity, more like a liquid metal. This metallic hydrogen layer is one reason Jupiter has such an enormous magnetic field, and that magnetic field is terrifying. Jupiter's magnetosphere is the largest and most powerful planetary magnetic field in the solar system. It is so huge that if we could see it with our eyes from Earth, it would appear larger than the full moon in the night sky. This magnetic field traps charged particles and creates intense radiation belts around Jupiter. The radiation near Jupiter is so strong that it can damage spacecraft electronics. A human exposed to it without extreme protection would not survive. The Juno spacecraft, which entered orbit around Jupiter in 2016, had to be built like a flying armored vault. Its sensitive electronics were placed inside a thick titanium box to protect them from Jupiter's radiation. Even then, the spacecraft must carefully manage its orbit to reduce exposure. That is how hostile Jupiter's environment is. It is not enough to survive the storms. You must also survive the radiation, and the pressure, and the heat, because deeper inside Jupiter the temperature rises dramatically at the cloud tops. It is freezing, but as you fall inward, the pressure compresses the gas and the temperature climbs, thousands of degrees, then tens of thousands of degrees. Deep inside Jupiter, temperatures may reach around 20,000 degrees Celsius or more. Some estimates for the core go even higher, that is hotter than the surface of the sun. Anything falling that deep would be crushed, heated, torn apart, and vaporized. There is no version of this journey where a human survives. There is no hidden surface, no place to land, no cave, no ocean you could float on. Jupiter is a world that destroys anything that tries to enter it. From far away it is beautiful. Up close, it is deadly. And yet Jupiter may also be one of the reasons Earth is still here. For a long time, scientists have discussed Jupiter's role as a kind of gravitational shield. Because Jupiter is so massive, its gravity strongly influences comets and asteroids passing through the solar system. Some objects that might otherwise travel into the inner solar system can be deflected by Jupiter. Some are captured, some are thrown away, some crash directly into Jupiter itself. In 1994, humanity saw this happen. A comet called Shoemaker-Levy 9 had been torn apart by Jupiter's gravity. Its fragments slammed into Jupiter one after another, creating enormous dark scars in the atmosphere. Some of those impact scars were larger than Earth. For the first time, humans watched a major cosmic collision happen in real time on another planet. It was a reminder that Jupiter is not just sitting peacefully in space. It is actively shaping the solar system. Its gravity can redirect destruction, sometimes away from Earth, sometimes toward other places. This does not mean Jupiter protects us from everything. The solar system is complicated, and Jupiter can also send objects into new orbits that may become dangerous later. But there is no doubt that Jupiter is one of the most important gravitational forces in our planetary neighborhood. Without Jupiter, the history of impacts in the inner solar system might have been very different, and if Earth had suffered too many catastrophic impacts, complex life might have struggled to survive. So Jupiter is both a danger and a guardian, a giant planet that can destroy anything that approaches it, but may also have helped make Earth safer over billions of years. Now let us talk about one of Jupiter's most surprising features. Jupiter has rings. Most people know Saturn has rings. Saturn's rings are bright, beautiful, and easy to recognize. They are made mostly of ice particles which reflect sunlight very well. That is why Saturn looks so elegant through a telescope. But Jupiter also has rings. They are just much harder to see. Jupiter's rings are faint, thin, and dark. They are made mostly of tiny dust particles, not bright ice chunks. These particles reflect very little sunlight, and Jupiter itself is extremely bright, so the planet's glare overwhelms the faint ring system. For thousands of years, humans watched Jupiter in the sky without knowing it had rings. They were not discovered until 1979, when the Voyager 1 spacecraft flew past Jupiter and revealed them. That discovery changed the way we saw the giant planet. Jupiter was not just a striped gas giant with moons. It also had a delicate ghostly ring system, not as grand as Saturn's, not as obvious, but beautiful in its own quiet way. Where do these rings come from? They are likely made from dust knocked off Jupiter's small inner moons by impacts from tiny meteoroids. When small space rocks hit those moons, they blast dust into space. Jupiter's gravity then spreads that dust into thin rings around the planet. So Jupiter's rings are constantly being created and replenished by tiny collisions. They are faint traces of impacts orbiting silently around the largest planet in the solar system. And then there are Jupiter's auroras. On Earth, auroras are already breathtaking. Green, red, purple, and blue lights ripple across polar skies like glowing curtains moving in the dark. But Jupiter's auroras are far more powerful. In fact, Jupiter has the most powerful auroras in the solar system. Auroras happen when charged particles are guided by a planet's magnetic field into the atmosphere. When those particles collide with atoms and molecules in the atmosphere, they release energy as light. On Earth, most auroras are caused by charged particles from the solar wind. The sun sends out a stream of particles. Earth's magnetic field catches some of them, and they are funneled toward the poles. There they collide with oxygen and nitrogen in our atmosphere, creating beautiful colors. Jupiter's auroras work in a similar basic way, but with one major difference. Jupiter has an extra source of charged particles. Its moon, Io. Io is the most volcanically active world in the solar system. It is covered with volcanoes that constantly erupt sulfur and other materials into space. These particles become trapped in Jupiter's magnetic field, forming a huge donut-shaped cloud of plasma around the planet, known as the Io plasma torus. As Jupiter rotates, its powerful magnetic field sweeps through this plasma, generating enormous electric currents. These currents help create auroras around Jupiter's poles. Because Io keeps feeding material into Jupiter's magnetosphere, Jupiter's auroras can be almost permanent. Earth's auroras come and go depending on solar activity. Jupiter's auroras can keep glowing, powered by both the solar wind and its volcanic moon, and they are enormous. Jupiter's auroral regions can be larger than Earth itself. Most of the light they produce is ultraviolet, which human eyes cannot see. That is why telescopes like Hubble and the James Webb Space Telescope are so important. They allow us to view Jupiter in wavelengths beyond human vision. In 2022, the James Webb Space Telescope captured an extraordinary image of Jupiter. In that image, Jupiter looked almost unreal. Its faint rings were visible. Some of its moons could be seen nearby, and around its poles, its auroras glowed brightly, revealing the invisible power of its magnetic field. It was a reminder that Jupiter is not just a giant ball of gas. It is an active, energetic, dangerous, beautiful world. A world where storms rage for centuries, where auroras burn above the poles, where rings made of dust circle silently, where moons are pulled and heated by gravity until their interiors become oceans or volcanoes, and those moons may be the most fascinating part of Jupiter's story. Jupiter has many moons, but 4 of them are especially famous: Io, Europa, Ganymede, Callisto. They are called the Galilean moons because Galileo Galilei observed them in 1610. That discovery changed human history. Before Galileo, many people believed everything in the heavens revolved around Earth, but when Galileo saw 4 small objects orbiting Jupiter, it proved that not everything revolved around our planet. There were other centers of motion in the universe. Jupiter had its own miniature system, a planet with moons orbiting around it, almost like a small solar system. Each of the 4 Galilean moons is extraordinary. Io is a world of fire. It is covered with active volcanoes, constantly reshaped by eruptions. Its surface is yellow, orange, black, and white, stained by sulfur and volcanic material. Why is Io so volcanic? Because Jupiter's gravity squeezes it. As Io orbits Jupiter, it is also pulled by Europa and Ganymede. These gravitational tugs stretch and flex Io's interior, creating tidal heating. The inside of Io is constantly kneaded by gravity. That heat powers its volcanoes. Europa is the opposite. It is a world of ice. Its surface is covered by a bright icy crust, cracked with long reddish-brown lines. But beneath that ice, scientists believe Europa may hide a global ocean of liquid water. That ocean could contain more water than all of Earth's oceans combined. And where there is liquid water, energy, and chemistry, there is the possibility of life. Europa is one of the most promising places in the solar system to search for alien life, not intelligent life, not cities or creatures swimming under the ice, but perhaps microbes, tiny life forms surviving in a dark ocean, warmed by tidal heating, far from the sun. Ganymede is the largest moon in the solar system. It is bigger than Mercury. If it orbited the Sun directly instead of Jupiter, it might be considered a planet. Ganymede is also the only moon known to have its own magnetic field, like Europa. It may also have a subsurface ocean hidden beneath layers of ice. Callisto is ancient. Its surface is covered in craters, a record of billions of years of impacts. It is one of the most heavily cratered worlds in the solar system. Callisto looks quiet and frozen, but it too may contain a deep ocean beneath its surface. So Jupiter itself may be deadly, but its moons may hold secrets: fire, ice, oceans, volcanoes, magnetic fields, possibly even the ingredients for life. This is why scientists keep sending spacecraft to study Jupiter. Voyager flew past it, Galileo orbited it, Juno is studying it now, and future missions are being sent to investigate its icy moons in greater detail. Because Jupiter is not just one planet, it is an entire system, a giant world surrounded by rings, radiation, storms, magnetic fields, and moons that could each be explored for generations. The more we study Jupiter, the more we realize how strange our solar system really is. Earth feels normal to us because we live here. Solid ground, blue sky, liquid water, breathable air, gentle gravity, a stable surface. But Jupiter reminds us that planets can be completely different. A planet can be made mostly of gas. A planet can have no surface. A planet can have storms larger than Earth. A planet can spin in under 10 hours. A planet can generate a magnetic field so large it dominates millions of kilometers of space. A planet can destroy any spacecraft that ventures too close to its radiation belts. A planet can be both beautiful and lethal. And from hundreds of millions of kilometers away, Jupiter continues to influence us. It shines in our night sky. It shapes the paths of comets and asteroids. It protects, threatens, and fascinates. It holds clues about how the solar system formed. Because Jupiter was likely one of the first planets to form around the young Sun, its massive gravity may have shaped the architecture of the entire solar system. It may have affected where Mars formed, how the asteroid belt developed, and how water and icy bodies moved through the early solar system. In other words, to understand Jupiter is to understand part of Earth's own history. The story of Jupiter is also the story of how our solar system became what it is. So the next time you see Jupiter in the night sky, remember what you are looking at. That bright point is not a star. It is a planet larger than 1,300 Earths. It is spinning faster than any other planet. Its atmosphere is filled with jet streams, storms, and cloud bands. Its great red spot has been raging for centuries. Its gravity has swallowed comets. Its radiation can damage spacecraft. Its rings are faint and ghostly. Its auroras are larger and more powerful than anything on Earth. And around it, dozens of moons continue their silent orbits, including icy worlds that may hide oceans beneath their surfaces. Jupiter is not just big, it is majestic. It is violent. It is mysterious. It is one of the most important worlds in the solar system, and we have only just begun to understand it. If Earth is a small blue island of life, then Jupiter is the giant guardian standing far beyond us in the dark, a world too dangerous to land on, too massive to ignore, too beautiful to forget. It has no solid ground, no gentle weather, no breathable air, no calm surface. But it has storms that can swallow planets, auroras that glow in ultraviolet light, a magnetic field that reaches far into space, and moons that may one day answer one of humanity's greatest questions. Are we alone? Jupiter may be a planet of death, but around it, there may be worlds of possibility, and that is what makes it so unforgettable. It is not just the largest planet in the solar system. It is a cosmic giant, a storm king, a silent guardian, and a gateway to some of the deepest mysteries of life beyond Earth.